galaxies look permanent. 100 billion stars bound by gravity, spinning for billions of years. Surely you can't just delete one? Actually, you can. Given the right conditions, you can dismantle a galaxy completely, no explosions required. Here's the manual. Step 0. Know your enemy. A typical spiral galaxy contains 100 to 400 billion stars. That sounds like the hard part. It isn't. Stars are a rounding error. 90% of a galaxy's mass is dark matter, an invisible scaffolding that holds everything together through gravity alone. You can't see it, you can't touch it, but it's the reason the galaxy exists. The remaining visible matter, stars, gas, dust, just follows the dark matter's lead. Remove the scaffolding and the whole structure loses coherence. The total gravitational binding energy of a galaxy like the Milky Way, including the dark matter halo, is the equivalent of roughly 1 billion supernovae detonating at the same instant. You cannot brute force this. There isn't enough energy in any single event in the observable universe to blow up a galaxy in one shot. You need to be methodical, you need to be patient, and you need to attack from multiple angles simultaneously. Think of it less like demolition and more like siege warfare. You starve it, strip it, and let it consume itself. Step 1. Remove the scaffolding. Every galaxy sits inside a dark matter halo, a vast, diffuse sphere of invisible mass that extends far beyond the visible disk, sometimes 10 times farther. This is the skeleton. Remove it, and everything else loses its anchor. The method is called tidal stripping. Send your target galaxy on a close pass with something much larger, a galaxy cluster, ideally, containing hundreds or thousands of galaxies. The bigger object's gravity peels away the outer layers of dark matter like pulling thread from a spool. The stars at the edges, no longer gravitationally bound, drift off into intergalactic space. The galaxy shrinks from the outside in. This isn't theoretical. Dragonfly 44 is a galaxy made of 99.99% dark matter. Something already stripped almost everything else away. Only the deepest core remains, a ghost of what it used to be. Step 2. Cut the supply lines. Galaxies don't manufacture stars from nothing. They need fresh gas, cold hydrogen, mostly funneled in along filaments of the cosmic web. These are the supply lines, thin rivers of matter connecting galaxies across millions of light years. Cut them off, and the galaxy starves. The process is called strangulation. Heat the gas in the surrounding halo so it can't cool and collapse into the star-forming disk. No dramatic explosion, no visible event. The galaxy simply stops receiving new material. Like cutting water to a city, nothing detonates. Everything just stops. Existing stars keep burning, but no new ones form. The galaxy doesn't know it yet, but the clock is now running. Step 3. Pressure wash the gas. This is the most visually spectacular method on the list, and it requires a galaxy cluster. When a galaxy falls to the hot gas between cluster members, the intercluster medium, heated to 50 million degrees, the pressure strips gas right out of the disk. Imagine driving to a fire hose at 10,000 miles per hour. This is RAM pressure stripping. The result? Jellyfish galaxies, long luminous tails of gas trailing behind the stripped galaxy, glowing blue with newborn stars. The galaxy is spawning offspring as it dies. Stars forming in the tails, born homeless outside any galaxy from gas that will never return. Some of these tails stretch 300,000 light-years long, longer than the galaxy that produced them, a beautiful slow-motion evisceration. Step 4. Activate the self-destruct. Every major galaxy has a supermassive black hole at its center. Most of the time, it sits quiet, dormant, but feed it funnel gas toward the center, and it becomes a quasar, one of the most luminous objects in the universe. A quasar doesn't just glow, it fights back. Radiation-driven winds blast outward at 10 to 70% the speed of light, shoving gas out of the galaxy entirely. relativistic jets, twin beams of plasma at 99.9% light speed, punch millions of light years into intergalactic space. Nothing in their path survives. The energy output of a single active galactic nucleus can exceed 10 billion supernovae. Every galaxy comes with a self-destruct button already installed. It weighs 4 million solar masses, and it's sitting right at the center, waiting. You don't need to add anything, you just need to press it. Step 5, burn the reserves. If any gas survives the previous steps, there's one final option. Use it all at once. A starburst episode converts gas into stars at an unsustainable rate, sometimes 1,000 solar masses per year compared to the Milky Way's modest 1 or 2. The galaxy blazes bright blue with massive, hot, short-lived stars. But massive stars die fast. The brightest burn through their fuel in just a few million years. And all that gas turned into stars, it's locked away now. Can't be recycled, can't form anything new. At starburst rates, the entire gas reservoir is gone in 100 to 600 million years. That sounds long, but for a galaxy, it's a weekend. The equivalent of burning your furniture to stay warm. Spectacular while it lasts. Terminal when it ends. Step 6, confirm deletion. The galaxy is now quenched. No cold gas, no star formation, no mechanism for recovery. The remaining stars age. Blue stars die first, they always do, leaving only long-lived red dwarfs and fading giants. The color shifts. The galaxy reddens, dims. Its spiral arms dissolve as differential rotation smears the structure into a smooth, featureless elliptical blob. Astronomers call this morphological quenching. The shape itself now prevents gas from assembling into a star-forming disk, even if gas somehow returned. Red, dead, and structurally incapable of recovery. Deletion complete. And this happens fast. The James Webb Space Telescope found a fully quenched galaxy just 700 million years after the Big Bang. The universe was barely 5% of its current age, and galaxies were already dying. Here's the thing. None of this is hypothetical. Every single mechanism in this tutorial is operating right now across the observable universe. Ram pressure stripping in the Virgo cluster, quasar feedback in distant AGN, strangulation in galaxy groups everywhere. Half of all massive galaxies are already quenched, already dead or dying. Their stars burning down like candles with no replacement wicks. Galaxies aren't permanent. They never were. Deletion isn't an exception. It's the expectation. The universe has been running this program since before Earth existed, and it will keep running long after every star you can see tonight has gone out. This isn't science fiction. This is Tuesday on a cosmic scale. This is Stardrift FM. Keep drifting.